Okay, so in this video, we're going to do the practical application part of what we learned in part 1, which is we're actually going to graph the transformation. Okay, so I invite my students to go ahead and draw as for a reference the standard parent function of whatever graph you're being asked to draw. So I have a standard sine wave, starts at 0, 0, it ends at 2 pi, which is the normal period or wavelength of a sine function. And, and then you set up how you're going to graph the transformation underneath it or in between or something. Okay, so let's take a look at this info. We have everything we need up here to be able to successfully graph this. So here's our original function, 1/2 sine of 2 theta. I'm writing theta there so that you get used to seeing it. You often see theta instead of x. It's the same thing. Minus pi fourths plus 2. So from the previous video, you saw that we calculated our lambda, our wavelength. It's pi because there's a horizontal compression of 2. All right, so you're going to get an entire graph in half the space that you normally would. Okay, the spacing between the points, the lambda divided by 4, is pi fourths. So every time we plot our next major point, we will add pi fourths to that number. Our starting point, which we also calculated by setting the argument to 0, all right, ordinarily sine graphs begin at 0, 0, but this one's being shifted to the right, pi fourths. So we have to account for that, and we did. We calculated that the starting point for our compressed graph is going to be pi eighths. So I also want to tell you guys right now that you usually have to convert fractions. When you do this by hand, just get used to the idea that because I'm starting at pi eighths, I want to keep everything in eighths. So pi fourths equals 2 pi eighths. So let's begin. So here's my starting place. My x-coordinate is pi eighths. My y-coordinate is 2. Remember, it's just k, the midline, the 0. So here's pi eighths, and there's 2. All right, plot my first major point. My second major point is my first point plus my space, and then my y-coordinate, because sine waves go up, I'm adding my amplitude. Okay, that's how this is done. So my point is 3 pi eighths, 2.5. We see it right here. 3 pi eighths, 2.5. Plot that point. My next point is just the previous point plus another 2 pi eighths. And because sine waves go back down, it's just going back to midline. So my third point is 5 pi eighths, 2 again. So 5 pi eighths right there, 2. Almost done. My fourth major point is my third point plus another 2 pi eighths. So 5 plus 2 is 7 pi eighths. And this time, because it's my valley, I'm going down, I'm going to subtract the amplitude from my midline, right? So that gives me 7 pi eighths, 1.5. 7 pi eighths, there's my x-coordinate, 1.5. And then last but not least, my fifth major point is my fourth point, plus another 2 pi eighths, and because sine waves go back up to 0, I'm going to go back to my midline. So my final point on my graph is 9 pi eighths right there, 2. So we have graphed a transformation. You can do this exact same procedure for any graph. Sometimes the designations get kind of wacky and you have to like guess. I mean, I've seen 15ths, pi 15ths, 18ths, but you can do it. And sometimes you just have to estimate the distances to if you can't plot it exactly. Especially with the CUDA graphs, you have to say, well, you know, a third of a pi thirds is 1 pi ninth. Okay, so you can figure it out. And I invite you to go ahead and try. So here you have it. See you in the next video.